Can you guys still hear me? Okay, awesome. All right, now I think it'll let me share my screen. When I tried to share my screen before, it said the host has disabled members from sharing their screens. Okay, so can everybody see the screen now? It should be, you should see the Zoom launching. You guys are seeing that now? Okay, so what I'm gonna do is I'm gonna go to our class, and I just wanted to point out a few things. Don't forget that by Thursday, you need to have done 3 things. You should do the syllabus quiz that's here. This is under content. Obviously, you guys found the content because you're here on the Zoom meeting. But under the start here, there's a syllabus quiz. Make sure that you do that by midnight on Thursday. And then in here, there is a quick video on how to use Connect Math. And I mean, you're welcome to even do that double speed or whatever if you've kind of used it before. Just kind of watch it real quick, make sure you got the basics of it. And then the link to Connect Math, this is how to get registered in Connect Math, and then here's the link to do it. Don't try to go to the Connect Math website and register there, because if you do it there, you need a class code. But I don't want you to do it that way. I want you to do it here, because then it links the grades in Connect Math right back to our grade book here in D2L. So your grade is constantly kept up to date, which is fantastic. Except for right now, if you have opened up an assignment and closed it, it gives you a 0 on it. Don't worry about that. When you go and work on it, it'll update the grade. So don't worry about that. It's just it's this quirk in Connect Math. I've actually messaged them, and they haven't done anything about it. I wish that they would fix it, but they don't seem to have any intention of doing so. So again, if you have a 0 in Connect Math right now on your grade in D2L, don't worry about it. When you go do your assignments, it'll update the grades and everything will be fine. Also, registering Connect Math and watching this video, I have to put those grades in by hand. So if you've done them but you don't see a grade, again, I'll do those later today. I'll probably update them today and then tomorrow and then Thursday. Like I'll do them like at least once a day until after the due date. And then after the due date, I'll put 0s in for the people that haven't done them. So if on Friday, you know, by the end of day Friday, you don't see a grade in there, then you can let me know. But otherwise, it should be fine. And it lets me know who's done it. So this lets me know who's done it by just doing like a completion. I have a completion list, and then I'll know whether you registered in Connect Math because you'll be registered in Connect Math. So I'll go put those grades in after people do them. Does anybody have any questions on that at all? Okay. Oh, also, when you do this quiz, if you don't like your grade, do it again. It has unlimited attempts. So keep doing it till you get a 25 out of 25 if you want to. That would be great. I want you to know what's on the syllabus. So if you missed it, if you've got, I don't know, 21 out of 25 and you're like, darn it all, then just go back and redo it. It's not limited at all on the attempts. You can do it 100 times if you want to. Hopefully it won't take you that many times to get a 25. But and then also what I'm going to be using today for notes, like on all of these, is I'm going to be using these PowerPoint notes. I don't have chapter 1 in here. I just realized this morning, and I don't know why. I can put those in there if I can find them. I don't know why they're not in here, but you can print these off and follow along with them if you want to. I'm hoping that this week we can get through chapter 1 and chapter 2 and maybe even get a little bit into chapter 3. I'm afraid that doing all of chapter 3 and 4 next week might be a little bit too much, but I'm hoping we can get through 1 and 2 and have a little extra time to get started on 3, and then we will get through everything by the end of next week. And lastly, and then we're going to go do some math. The other videos are already here. So This one needs to go away. So all the videos for the other sections are in this module here where it says Zoom link and recorded lecture videos, where you got to the Zoom link. All of the other videos are here from section 4.5 on, because I did Zoom classes with my spring class after we had to go online after spring break. So from 4.5 on is already in here. Except for 6.1. I'm going to make a video for 6.1, but all the rest of them are in here, and as well as some reviews and things. So like this chapter 7 live Kahoot review, the class and I were on a Zoom meeting. We did a Kahoot together, answered lots of questions about chapter 7. So when you're ready to take the test, you can go watch this if you want to and see the review for chapter 7. So there's lots of different options in here, but there's all the sections. Okay, and with that said, let me close this up and get to the And so this is what the PowerPoints look like. They just have slides. These slides are actually from the 7th edition book, because I don't like the slides that came with the 8th edition book. I don't think that they were as good. And so we're going to be using the slides from the 7th edition book. The only thing that matters is there's a couple times where the sections don't match up, like they split the sections just a little bit different, but I say it in the video. I'll say this is actually section whatever from your book. So right now it doesn't matter. These sections are still matched up the same way and everything. So without further ado, we're going to talk about chapter 1. Chapter 1 is kind of a strange chapter. It's a very short chapter, and it doesn't really have any true math in it. It's just a matter of, well, I guess there's one thing that's kind of math, but the rest of it is kind of an introduction and terminology and verbiage and things like that. The chapter is actually called The Nature of Probability and Statistics, and it's just kind of an intro to statistics. So we're going to talk about, in section 1.1, we're going to talk about descriptive and inferential statistics. That doesn't, it's not big enough. So in 1.1, we're going to talk about the difference between differential or descriptive and inferential statistics. And in 1.2, we're going to talk about variables and data. In 1.3, we're going to talk about data collection and sampling techniques. And then in 1.4, we're going to talk about experiments. It's technically called experimental design, but we're going to talk about what type of experiments you can do. So these are the 4 main topics, and this right here you could see descriptive and inferential statistics is where we're going to start. If anybody, again, if you have any questions, please don't hesitate to just jump in and ask a question. I want you to do that. You're not interrupting. We're here for you, or, I'm here for you guys. So I would love for you to ask questions. That's great. And if you're having a question on something, somebody else probably is too. So let's see if I can get rid of this way. Nope, that's not what I meant to do. There we go. Okay, so you'll notice that the very first sentence of our notes, it's kind of unusual. The very first sentence of our notes says that Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions. Well, why in a math class does it say in our first slide that statistics is a science? And the reason for that is because statistics is kind of a strange overlap between mathematics and science. It has a lot of things that are in common with science. If you look at this collect, organize, summarize, analyze, draw conclusions, that sounds like something you would do during a scientific experiment, kind of. So there's an overlap between the two. Statistics is not truly just a mathematics. It's not truly just a science. It's this overlap between the two. I like to think of it as it's a mathematics that supports science. It's a mathematics that was made specifically to support science, and actually not just science, social studies, or social sciences, all business, all these things. So it's a mathematics that can be used when you're researching in any other discipline. And then, let's see if we can get down to here. We have some definitions. So on the exam for chapter 1, all there is really on the exam for chapter 1 is some different questions about this terminology and things. So you want to make sure that when you take the exam that you're comfortable with the different terminology. It's not so much like a fill in the blank or anything. It's typically like a multiple choice or a true false kind of thing. So the first definition that we're going to talk about, or the first term that we're going to talk about, is what's a variable. And you're like, oh, I've taken algebra, I know what a variable is. A variable is like x and y and n, and it's what you solve for. Well, in statistics, a variable is not really the same thing. A variable in statistics is a characteristic or attribute that can assume different values. So in statistics, a variable doesn't even have to be a number. So a variable could be hair color. And so the characteristic is what is a person's hair color, and that can assume different values. It could be blonde, or it could be brown, or it could be black, or it could be gray, etc. So all those different colors of hair are the different values that it can assume. So in statistics, a variable is not what we typically think of it as in algebra. Now, we do have those types of variables within the equations and such also, but this is what they're talking about when they're talking about a statistical variable. Are these attributes or characteristics. And then of course it could be a number, because we could say number of credit hours that you've taken. So so how many credit hours have you taken? Well, I've taken 5. I've taken 22. So a variable in statistics can be a number, but it doesn't have to be a number. Okay, so the next thing is that the values that a variable can assume are called the data. So if someone says, I have blonde hair, that's the data for that person. That's the data that's been collected. So data, or data, however you want to pronounce it, is the actual things that it could assume. These two things, you'll be pretty comfortable with them because they'll use them a lot within the problems. These are probably not something I would ask about on a question. These two things, however, you really need to know the difference between what is a population and what is a sample. All of statistics is basically based on those two things. And the idea in statistics is that what we're trying to do, what we want to do in statistics, is we want to have information about a population. And that's what we want. The problem is that, I'm sorry, that's my dog. Hold on 1 second. Logan, you can't close the door because then she barks. Please open the door. Thank you. So the problem is that usually it's too large. So a lot of times with the population, you can't sample or find out something about everything or everybody in the population. So, let's be, really dramatic about it. Let's say you're trying to find out how tall sunflowers are. There is no possible way you could go out and measure the height of every sunflower in the world. That's the population you're looking at, sunflowers. But there's no way to go out and actually sample and find out the height of every sunflower in the world and then take the average of it or whatever you're doing. Usually, in statistics, the population is too large to get the information from every single individual in that population. And again, a population doesn't have to be people. It could be sunflowers, it could be people, it could be cars, it could be anything that you're studying. So population doesn't necessarily mean something that's living. Okay. So what we do, since our goal is to find info about the population, is we take a sample. So you take a sample of the population, and your goal is that this sample will be a good representation of the population. So say you're sampling people, and it's a general population of people, so it should be approximately 50-50 male and female. You would hope that your sample would come out about the same. If you're looking at a school and say a college, and within the college, roughly say 60% of the people at the community college are freshmen and 40% are sophomores, you would hope that your sample would represent that it would come out about the same. And the best way to do that, and I'm going to say this now, even though we're really not supposed to be doing this yet, the best way to sample is random. Always and forever. The best sample is to random sample. Not messing around with it and trying to make it a certain way. The best way to try to get your sample to represent the population is to do a random sample if you can. Problem is sometimes we can't. But that is always and forever the best way to sample a population, is to do a random sample. So for those visual people, let me draw a little Venn diagram here. So if this is the population, where should the sample be within that population, or where should the sample be in relation to this population?
Inside.
Inside, completely inside, right? Should my sample be like this?
It's no longer a representative of the population you're trying to get.
Right. So if you're familiar with Venn diagrams, you're exactly right. This out here would be things that aren't in your population. So you don't want to sample things that are outside of your population. So when you're doing a, let me see if I can do it this way. Yep, good. All right, so when you're doing a sample, you want to make sure that your sample is entirely inside of your population. You only want to sample from the population that you're trying to study. So if you're trying to study, say, students at Lone Star Kingwood, you wouldn't want to sample students that go to University of Houston, or students that go to any other community college, you know, Sanjack or something like that. If your population was Lone Star Kingwood, then you want to make sure that your sample is only students that go to Lone Star Kingwood College or Lone Star College Kingwood. You do not want to take students from outside of that. Now they could be in both. Like you could sample a student that went to both colleges, but they at least have to be a student at Lone Star College Kingwood before they're going to be included in your sample. So does anybody have any questions on any of that stuff before we move on? I'm going to clear this whole screen, so speak now or forever hold your peace. Okay. All right, so give me just a moment while I get our next couple slides up here. All right, let me make sure I haven't skipped one. We did that one, we did the variables. Now we're talking about descriptive. Okay, so the next thing that we're going to talk about, and this is actually the last slide for section 1.1. Like I said, chapter 1 is very short. The rest of the chapters, the sections are much longer. So when we're talking about statistics, there's two different types of statistics in general, just two basic overshadowing types. There's descriptive statistics and there's inferential statistics. As we're going through the class and you're trying to remember different terminology and definitions and things, try not to just remember them by memorization alone. Most of the things that we're going to talk about, if you think about what the word means, it helps you a lot to remember what it is. So when you look at the word or the term descriptive statistics, what's the base word of descriptive? Like in English, what would be the base word of descriptive?
Describe.
Describe. And that's exactly what descriptive does. Oh, now my pen's having a day. There we go. Okay, so the base word of descriptive is describe, to describe. That's what descriptive statistics does. It is the collection, organization, summarization, and presentation. It stops at that point. It doesn't go on and make any kind of determination of relationships. It doesn't predict anything. It doesn't estimate. It just describes what was collected. So it goes, you know, in descriptive statistics, you do your collection from your sample, you organize it, you summarize it, you may present it, but you stop at that point. So you stop at the describing part. Might help if I spell this word right. So that's descriptive statistics. So how does inferential statistics, or how do inferential statistics differ? Well, what's the base word of inferential?
Infer.
Infer. So the base word of inferential is infer. What does it mean to infer? Well, if you think about it in everyday language, when somebody says, are you inferring? They usually mean, are you trying to make a leap from the information to some sort of conclusion? So, well, I saw that you were, I see that you were out until, 1 a.m. You could say, are you inferring that I was doing something wrong? I was at work. you know, that when somebody infers from the information that they have, they're making some sort of conclusion or prediction or estimation of what happened. Is that always correct? No, it's not. When you're describing, you're just describing. But when you start to infer, then you have to make some, you have to use some of your past knowledge and things like that to try to, you're basically kind of guessing. And what you're trying to guess is an estimate. You're trying to determine relationships, and you're trying to make predictions. So if I just report, you know, the enrollment for the past 10 fall semesters at Lone Star, if I just report that, the enrollment in fall of 2010 was this, the enrollment for the fall of 2011 was this, and I stop short of that. I just report it. I list all 10 fall semesters, I say what the enrollment was, and I stop there. That's descriptive. If I try to predict what the fall enrollment for this year is going to be using that data, then I'm doing inferential. So if I just report it, that's descriptive. If I try to guess the fall 2020 enrollment, now I am doing inferential statistics because I'm trying to make a prediction or an estimation or a relationship between what happened the past 10 fall semesters to what's going to happen in the next fall semester. Does anybody have any questions on that? You'll have practice, you know, when you're doing your homework, you'll have some practice on this. And I guarantee you'll understand it or think you understand it, and you'll mess up on a couple of the homework problems. It's okay. There's, you know, some things about it that can be a little bit quirky. But remember that if it's inferential, if it makes that leap into inferential statistics, they have to be making an estimation or trying to figure out a relationship or make a prediction. If they're just describing, even if they're organizing it and summarizing it, that's still just descriptive. Anybody have any questions on that? Okay.
So wait, in qualitative and like quantitative, can they both be like descriptive and inferential, or like is it kind of one or the other?
No, hold on one second. So let's go down to that slide. So qualitative and quantitative data can both be descriptive and inferential. Qualitative and quantitative is just a matter of what type of data it is. So like when we were talking about hair color, having a problem with my pen. It wants to not write every once in a while. Hold on a second. It might actually be my tablet. Let me try to go down a little bit. Okay, so qualitative are things that are only categorical, like hair color. Quantitative would be your semester hours. And either of these, you could do descriptive or inferential statistics. So if qualitative would just be collecting data on people's hair color and reporting it. Same thing here with quantitative, you would just collect data on people's semester hours and report it. You wouldn't make any kind of predictions. Now, if I wanted to say, this is what I found out about hair color, so I'm going to walk into this classroom and try to predict how many people are going to have blonde hair and how many people are going to have brown hair and how many people are going to have black hair, now you're making an inference. Or if you even want to say, I'm going to try to say that the population has, you know, 20% of the people have this color hair, 30% of the people have this color hair. Again, you're making an inference. You're not just reporting. but you could do the same thing with quantitative data. So these could be either one. So these are the main types of statistics, and these are types of variables. Does anybody have any questions on that? I'm going to talk more about what qualitative and quantitative is. But does it make sense that you can do, it doesn't matter which type of data is, you could do either type of statistics? Okay. So when we're talking about qualitative and quantitative, again, try to remember what these are saying. What's the base word of qualitative?
Quality.
Quality. So when you're talking about qualitative data, you're talking about a type of variable that is just a quality or a category or a characteristic. So it's just a characteristic. It's not usually a number. It can be a number, but it's not usually a number. So we're talking about qualitative data. It's just a quality about something. So if I say, again, I don't know why I'm stuck on flowers, maybe because it's spring in Texas, but you know, if I say 70% or 40% of wildflowers in Texas are yellow, some shade of yellow, that's a quality of the flowers. If I talk about how tall the flowers are or how many grow within a certain square foot or square yard, now I'm talking about a quantity. So a quality is just a characteristic. It's usually just a category. It's typically not a number. We'll talk, there's a couple weird types of numbers that can be qualitative, but it's typically not a number. So now let's go over to quantitative. What is the base word of quantitative?
Quantity.
Quantity. Well, quantity means number, right? So when we're talking about a quantity of something, we're saying we counted it. We can say what the quantity of that is. I went to the store and I bought 17 items. That's the number of items I bought. The quantity of items I bought is 17. I asked somebody how many semester hours they took. They told me they'd taken 22 semester hours. That's a quantity. So quantitative data is a quantity or a number that can actually be counted and ranked. So you'll notice here in our little chart, it says quantitative is numerical and it can be ranked. So it has to be a number and it has to be able to be ranked. Sometimes a number can't be ranked and that would make it qualitative. Again, we'll have some examples of that here in the next couple slides. Now within quantitative, you can have two types of quantitative data. You can have things that are countable. Well, and I just said they're all countable. You can't always necessarily count them, but you can describe with a number. So if it can be counted, like how many items I bought at the store or how many semester hours I've taken, we call that discrete. For our book or for our purposes, they'll be whole numbers. Okay, so if it's whole numbers that you can count, that's discrete quantitative data. So semester hours, how many items you bought, how many pets you have, how many, well, I won't say that one because that could actually be continuous. I was going to say how many miles you live from campus, but that could be continuous depending on how you describe it. Because if you say how many miles you live from campus, round it to the nearest mile, that could be discrete. But if you say how many miles do you live from campus and you let people say, you know, to decimal places, then we would consider it continuous. So continuous, again, for our purposes, if it has decimals, then I should have wrote that the other way around, but So if it has decimals, we'll consider it continuous. If it's decimals or fractional parts, we'll consider it continuous. And so the difference is, if you think of a number line, you know, here's 0, 1, 2, 3. Most data that we're collecting is positive. You can have some negatives in some situations, but most of what we'll deal with is just positive numbers. So if, when you're looking at something, you can only have 0, 1, 2, 3, etc., that would be what type of data?
Discrete.
Discrete. But if you can have, so that would be discrete. But if you can have something in between here, you could have, you know, 0.37, 1.8. You know, of course, you could have 2.0. But if you can put numbers in between these, then we'll consider that continuous. If you can have parts of something. And continuous, again, what we mean is it's continuous. It doesn't jump. It doesn't go from 0 to 1, 1 to 2. It continues between those numbers. That's why it's called continuous. Discrete in mathematics usually means that it has gaps between it, or that it has very specified things. Any questions on that before we go to the next slide? Okay. Again, I'm going to clear this completely. So if anybody has anything you want to ask about on this, say so now. Okay. So now we're going to look at I thought we had some examples of, I thought the next slide had some examples of discrete and continuous. It does not. So let me actually stop, not do the slide. Let's actually do some examples of these. Sorry, when you see that on the screen, I'm having problems with my tablet. And I apologize. I used to say when I was in class that I always hated when you pick up a marker, sometimes it wouldn't write. And I wish I just had chalk. Now I wish I just had a whiteboard. Okay, so discrete and continuous. If I said, let's just throw a few out there, the number of pets someone has, is that discrete or continuous? Number of pets someone has.
Discrete.
Discrete. Because unless you get weird, like, you know, like kids will do, you wouldn't say, oh, I have 2 dogs, but my girl dog is pregnant, so I have 2.3 dogs. You wouldn't say something like that. You typically, when you're collecting pet data on how many pets someone has, they have no pets, 1 pet, 2 pets, 3 pets. What about somebody's height? Or basically any height. It could be height of how high a ball bounces.
Continuous?
Yes. Continuous, yep. That would be, typically height would be continuous. Again, you could, the researcher could make it discrete by saying, I'm going to round to the nearest foot or something like that. I'm going to round to the nearest inch, not allowing any decimals. They could make it discrete, but in theory, it's continuous. Because somebody's height could be, or the height, we'll go with metric because it's a lot easier. So if you're measuring the height of a ball, how high it bounces, you could say, well, this ball bounced, you know, 10.2 centimeters high. And so that would be considered continuous because you're not stopping at 1, 2, 3, 4. What about, well, we already talked about number of credit hours. What about the weight of something?
Continuous.
Continuous. Again, you could make it discrete, but if you're just weighing something, there's nothing that says that it has to stop at, you know, be 1 pound or 2 pounds or 3 pounds. It could be 1 and part of a pound, 20 and part of a pound. So when you can go between that. not feeling very, I'm not coming up with great things right now. But if you, again, distance, that would be continuous. You notice a lot of these are measurements. Most measurements are going to be continuous. Oh, Lord, did I just lose everybody? Are you guys still there? Because my little screen of you guys went away.
I'm still here.
You guys are still here?
I'm still here.
Okay.
Yes.
I don't know why the little screen of everybody went away. That scared me for a minute. I thought we lost connection completely. Okay, so now let's go ahead and go to the next slide. And we're going to talk about boundary values. These tend to, this is the one thing that's kind of mathematical about this chapter. And these tend to kind of bother people. So I'm going to kind of start with something before we start talking about this slide. So if you were looking at, and I guess we're kind of talking about the first thing on this slide, but if you were measuring something, and let's say you decided that when you're measuring, you're going to measure to the nearest centimeter. You've decided, I'm going to measure to the nearest centimeter. And you go out and you take your yards, your measuring stick or your tape measure or whatever you're measuring with, and you measure something. And you write down for your measurement for that item, you write down 15 centimeters. What could you have measured that item in order for you to write down 15 centimeters? What measurements could you have gotten that would have given you 15 centimeters for your result on your table that you're filling out or whatever? What's the smallest thing you could have measured that you would have written down 15 centimeters?
14.5.
14.5, because typically in mathematics, if you're rounding to the nearest whole number and you get a 14.5, you would write down 15, right? Is everybody okay with that? So if you had gotten 14.5, you would have written down 15. Are you guys okay with that? That makes sense? Yes? Okay. What's the biggest number? What's the number that you would have gotten that would have caused you to stop writing 15? In other words, where's that limit at that you would stop writing 15? So what's just over the biggest number that you would write as 15? 14.5, yep, 15.5, right? Is that what you said? I think that's what you said.
Yeah.
Yeah. So 15.5, right? So everywhere up to 15.5, you would write 15. And I actually shouldn't write that with that kind of bracket. Let's do it like we would have done in algebra class. When it got to 15.5, you would have all the way up to 15.5, you would have written as 15. But once you got to 15.5, you would write it as what?
16.
16. So let me go back here and mark. So the next number down is a 14. The next number up would be a 16. But anywhere between 14.5 to 15.5, you would have written back as 15 if you were measuring to the nearest centimeter, okay? So these values, this 14.5 and this 15.5, those are considered the boundaries of 15. They're called the boundary values. We use these when we do some graphs in the next chapter. That's when we're going to kind of use this, these boundary values. So it's a matter of understanding, you know, where could 15 have come from? Well, 15 could have come from anywhere from 14.5 up to 15.5, but not including 15.5, because 15.5 we would have actually gone up to 16. But we still consider those the boundaries, even though one's like a closed boundary and one's like an open boundary. So far, so good? I know it's a little bit confusing. This is something that bothers people a little bit. Okay, so let's erase these numbers. And let's see if we can do it with some other numbers in this table. So if I'm going to go down here to the mass. So let's say we were measuring mass to the nearest. What does it look like they're measuring to? They're not measuring to the nearest gram. What are they measuring to? Just in general, they're measuring to the nearest what? It's not whole. They're not measuring to the nearest gram. They're measuring to the nearest tenth. Okay, so you have to know that. You have to know what's being measured. So in this case, or how it's being measured. They're measuring to the nearest tenth of a gram. See if I can squeeze this in over here. Okay, so they're measuring to the nearest tenth of a gram. So 1.6 grams is what was reported. What are the boundaries of 1.6? So I'm going to do this in a little bit different order because I think it's a little easier than the way I did it before. What would be the next number, the next reportable number under 1.6? What would be down here? Mm-hmm. And then the next reportable number above 1.6 would be 1.7, right? So now, what are the boundaries of 1.6? What would cause us to report a 1.6 and what would cause us to stop reporting 1.6? What would this number be?
1.55.
1.55. And then this would be 1.65. So when you're doing these problems on your homework, it might help you to write this out, at least in some form. So your number down here is 1.5. Your next reportable number is 1.6. Your next reportable number is 1.7. So the boundaries of what would be reported as a 1.6 are from 1.5 up to 1.65. This is where you would start reporting it as 1.6. This is where you would stop reporting it as 1.6 and start reporting it as 1.7. What do you guys think? Somewhat okay? If you're taking notes, try to do, I'm going to do the temperature one next. Try to draw yourself your little number line here for the next one. This one we have temperatures, and it's again recording to the nearest whole number. So they're recording to the nearest degree, nearest whole degree. So try to fill in these numbers like we were doing for 86 degrees Fahrenheit. And of course, 86 degrees would go here. Okay, so what did you write for this number that's the number that could be reported below 86?
85.
85, okay. And above 86, the next reportable number would be 87. Again, because we're going to the nearest degree. So 85, 86, 87. So they basically made this discrete, even though you could have part of a temperature they made 85, 86, 87. We're not really talking about that right now, but it would be discrete the way that they've defined it to the nearest whole number. And then what would be the reportable values, or between what reportable values would you get an 86?
85.5.
85.5. And then this would be
86.5.
86.5. Okay, so perfect. So these would be the numbers, these would be the boundaries for 86, 85.5 and 86.5. You'll notice that whatever is reported, the boundaries go one more decimal. So if it's reported to the nearest whole number, the boundaries are going to be the 10th. If it's to the nearest 10th, the boundaries are going to be to the 100th. So now the most difficult one here, because this one is actually being recorded to the nearest what?
10th. 100th.
100th, yeah, that one's being measured to the nearest 100th. So they're measuring to the nearest 100th of a second, which is how a lot of sports events are, you know, if you're watching some sort of racing event, whether it be cars or swimming or running, anything like that, they usually measure it to the nearest 100th second. And so let's fill this in. Because it's to the nearest 100th, that means our boundaries are going to have to be to the 1000th. So in the middle, we're going to have the 0.43. Okay, what's the reportable value under 0.43 if you're reporting to the nearest 100th?
0.42.
Or 2, and then the reportable value above 0.43 would be 0.44. And so the numbers that would cause us to go to report as 0.43, the first one would be 0.435, right? I'm sorry. What should that be? 25. Sorry about that. Okay, so all the way up, if I had 0.421, 0.422, 0.423, anything up to 0.425 that wasn't 0.425 yet, I would report it down. But once I get to 0.425, I report that as 0.43. And then I would stop at 0.435. Because at 0.435, I would report that as 0.44. What do you guys think? You okay with that? Okay. And again, when you're doing your homework, you always have like more than one attempt. I think on the homework, the way I have it set on most assignments is you get like, it'll give you a problem and you'll get 3 tries. And then after those 3 tries, what did I just do? After those 3 tries, it'll say, you're out of tries, would you like to, and then you can click try another, and it'll give you another problem and you get 3 more tries. And then if you mess that up, you can do another. So you get like 3 tries on 3 different problems for a total of like 9 tries. I want the homework to be homework. It's not supposed to be a test. You're not supposed to understand it, everything perfectly the first time you do it. And if you miss a problem, you don't have to, so like let's say you get done with an assignment and you got an 80 on it, you can go back and redo any of the problems within that assignment and fix them. Again, just like if you were doing homework. If you were doing homework out of the book, writing it down on paper, and you missed one, you wouldn't go, oh, the whole assignment is wrong, rip up your paper and throw it away. You'd go back and find the problems that you missed and fix them. That's how the homework is set up. So the homework is set up so that you have multiple attempts and you can jump back and forth between problems and you can fix one problem without redoing the whole assignment and all of that. If anybody has any questions on that when you're doing your homework, don't hesitate to shoot me an email and ask me about it. But it'll say you're out of attempts, but you'll notice there'll be a button that'll say try another. Okay, so the next thing that we're going to talk about are levels of measurement. And levels of measurement, I don't like the way they wrote it here. I'm going to write it in a different way. So I like to think of levels of measurement as either like a Venn diagram or as a kind of a pyramid. So I'm going to do it as a pyramid. So at the bottom of this pyramid is nominal data. Oh, pen, my pen, my pen. Okay, so we have at the bottom of the pyramid nominal data. The next level of the pyramid is ordinal. The next level on the pyramid is called interval. And then at the top we have ratio. So it's kind of like climbing a mountain. It's harder for something to be ratio level than it is interval, ordinal, or nominal. Also, in addition, once you've reached the nominal, or once you've reached a higher level, you've also reached all the other levels. So if something is interval data, that means it's also ordinal and nominal. So once you've surpassed a level, you've collected that level. So if something reaches the ratio level, it actually is all four. If it's ratio, it's also interval, ordinal, and nominal. And I know we haven't talked about what any of them mean, but does the kind of the pyramid idea kind of make sense? That as you surpass one, you've included it? If you wanted to think of it as a Venn diagram, you can too, but I think it just gets a little clustered. It would basically be kind of like a target. So the outer would be nominal, and then within nominal would be ordinal, within that would be interval, and within that would be ratio. If you'd like to think of it that way, you can, but I think that's more confusing than the pyramid idea. My pen is not being cooperative. Okay, so what makes each of these? Well, the first one, when we're talking about levels of measurement and types of data, nominal is anything. Everything, every type of data is nominal because it's just a category or a name. So for instance, hair color is nominal because you could just say, again, blonde, black. We don't usually give hair color a number. I know they try to on, you know, when you're looking at, say, boxes at Walmart for dyeing your hair, they try to give them numbers, but do they ever really make a lot of sense? No. Like, do you know if red number 7 is darker or lighter than brown number 5? You never know what the numbers, you know, mean. Different companies use different things. It's pretty hard to put different colors in some certain order. You know, somebody could say, well, I have brown hair, so it's darker than somebody with blonde hair. No, not necessarily. You know, there's light brown and dark blonde and dark red and gray and all kinds of different things. So it's pretty hard to put those in any sort of order. Everybody kind of understand the idea of nominal? Nominal means you can't really order it or anything like that. You just can give it a name. Okay. Then we go to ordinal. Ordinal, remember, if you're ordinal, it means you're nominal. So if we're at this level, we've already surpassed nominal. Now we're trying to say, have we also climbed the mountain up to ordinal? Ordinal means that we can rank it. And you're saying, okay, well, what could be ranked? What types of things could be ranked? Well, even things that aren't numbers could be ranked. So if I said, you know, freshman, oh my goodness. Come on, pen, we can't do this right now. So if I said freshman, sophomore, junior, senior, those aren't numbers, but they could be ranked. There may be related to numbers, but just saying freshman, sophomore, junior, senior, you could rank that. A freshman is, lower class than a sophomore, is a lower class than a junior, is a lower class than a senior. And I don't mean class like as in how good they are. I just mean like less credits or haven't gone to school as long. If you're looking at some sort of something you're buying, a drink you're buying, that a small is going to be less drink than a medium, is going to be less drink than a large, is going to be less drink, because we live in the United States, than a jumbo. Okay, so as we could put these words in order. So these would be considered ordinal, even though they don't have numbers with them. So nominal is usually just a name. Ordinal, you can put in order. That's where the name comes from, ordinal. And then the next thing is interval. So when we're talking about interval, we have to have consistency. So one that I like to show that is ordinal but not interval is grades. So in a typical grading scale, we can order these, and the same thing with the drinks. An A is typically a 90 to 100, right? A B is typically 80 to 89. C is usually 70 to 79. D is 60 to 69. And then what's an F?
Anything less than a 60, so 59 and under.
Yeah, so anything from 0 to 59. So this does not have consistent ratios or consistent intervals. Here you have 11 grades that could be an A, 90, 91, 92, all the way up 99, and then 100. So you actually get 11 grades that give you an A, or 11 scores. You only have 10 scores that can get you a B, 10 that can give you a C, 10 that can give you a D, and then you have 60 scores that could give you an F. So these are not consistent intervals. Same thing if we think about like small, medium, large. Let's say a small is 8 ounces. A medium could be 16 ounces, while a large is 20 ounces. Are those consistent intervals? How much was added from small to medium?
8.
8. And then here we added another 4, right? And then let's say jumbo is 32 ounces. Those aren't consistent intervals at all. So in order to be interval, you have to be able to put it in order, but you must have intervals that are consistent. And then the hardest level to reach at the top of the mountain here is ratio. And by the way, usually students, or a lot of students, will remember this with some sort of acronym. So they'll remember like NOR or something like that, nominal, ordinal, interval, ratio, to try to remember how they go. So just something like that.
What would be something that is consistent for the intervals?
Hold on just a second. Let me get rid of some of this junk on here. Whoops, I don't want to get rid of that. So something that is consistent, throw some things out there. What do you guys think? What would be something that might be consistent intervals? Stopping at the interval level is actually kind of hard, but.
Could you say class rank is if it's 30 hours grade level?
So if a freshman was defined as 0 to 30 hours and then a sophomore was 31 to 60 or something like that.
Right.
It could be. That gets a little tricky though too, because then the first one typically has, 0 to whatever. So it's kind of like the grades where you have 90 to 100 instead of just 90 to 99. One thing that reaches the interval level that doesn't reach the ratio level is temperature. So when you record the temperature, if you go from 68 degrees, then you have 69 degrees, then you have 70 degrees, then you have 71 degrees. So each jump is how much?
1 degree.
1 degree.
1 degree. So the intervals between degrees are 1 degree. So you don't have to, if you're at 70, your next choice doesn't have to be 72, it's going to be 71. And it does that all the way up and all the way down. So there's just a jump of 1. Usually intervals, I mean, not usually, but almost always an interval has to be a number because you have to be able to count if it's, consistent between the intervals. Another one that they use a lot would be like scores on some sort of a test. So you could have an 81 on the test. What would the next score be? 82. The next score would be 83. So they go 1 each time. It doesn't have to necessarily be 1, but if they have that equal interval all the way up and down. So scores, you could rank the scores, and each score would be 1 higher or 1 lower than the one beside it. Does that help a little bit? Okay, so let's go to ratio, and I'm going to leave the temperature up there for a minute because we're going to talk about how temperature is not ratio. So temperature does not reach the ratio limit for 2 reasons. When you're talking about ratio, you have to have the ratios have to be consistent, and there has to be a true 0. So what do we mean by ratios consistent? Temperature fails both of these things, by the way. So when I say the ratios are consistent, what I'm saying is that if I say a temperature of 40 degrees versus a temperature of 80 degrees, does that mean it's twice as hot? So when I multiply something or cut something in half or in thirds, if I divide it or multiply it, does it mean what it should mean if you double something or cut something in half? Is 80 degrees twice as hot as 40 degrees? Could we really say that legitimately? If somebody went outside and said, here it's outside at my house, it's 40 degrees, and you're talking to your friend on the phone that lives someplace else, and they're like, wow, here it's twice as hot as that. It's 80 degrees. You'd be like, okay, well, yeah, it's twice the temperature, but that doesn't necessarily mean it's twice as hot. That's just kind of weird. It's very relative. What, some people would consider, depending on where you live, 40 degrees might be nice. Other places, if you lived in, say, the northern part of Finland, let's say, 40 degrees might feel pretty good one day. And 80 degrees might be really hot or feel really hot. Here, 80 degrees, we're like, oh, let's go get the sweatshirt out, because 80 degrees around here isn't considered that hot. So temperature is very relative. Even though it has, specific numbers that we give it, it's very relative. It's not, the ratios aren't consistent. You wouldn't say, again, that 80 degrees is twice as hot as 40 degrees. Another problem with temperature is, in order to be ratio, you have to have what's called a true 0. So when we have a 0 degrees, is that the lowest we can go? Is that truly 0 temperature?
No.
No. You can have negative temperatures, right? Maybe not here in Houston, but, Definitely all around the world, you can have temperatures that are below 0 degrees Fahrenheit, even 0 degrees Celsius. And you might think to yourself, now wait a minute, I've heard of something called absolute zero. Wouldn't that be it? No, absolute zero is when, I believe, and somebody can correct me if I'm wrong, I believe it's when the atoms on Earth, when it's so cold that the atoms stop moving. But there's colder places than that in the galaxy, you know, in other places. So even true zero, or absolute zero, what we call absolute zero, is not the coldest something could be. So temperature fails both of these. There's no true zero. We don't have a limit of how cold something can be. And you can't, you know, saying something is twice as big is not twice as hot. So let's look at something that is ratio. Let's say you're talking about the height of something, and we'll do, say, how high a ball bounces. What's the lowest that a ball could bounce? We're measuring in inches or centimeters. 0. Yeah, let's do centimeters. So your ball could bounce 0 centimeters. So if you had, say, a bowling ball that you're dropping on cement, you would probably measure that as it bounced 0 centimeters. Okay. Maybe there was some bounce, but you know, measurably 0 centimeters. However, if one ball, let's say you had, you know, a tennis ball versus a basketball or something like that, if one of the balls bounced 10 centimeters and another one bounced 20 centimeters, could you say that the 10 centimeter bounce was half as high as the 20 centimeter bounce?
Yes.
Absolutely. That means something. 40 degrees, 80 degrees, is that twice and half? I don't know. But we're talking about height. 10 centimeters is definitely half as high as 20 centimeters. If you said one bounced 18 centimeters and another bounced 6 centimeters, then you could legitimately say the one that bounced 6 centimeters was a third as high as the one that bounced 18 centimeters. The ratios are consistent, and there is an actual true zero. You could bounce no centimeters, 0 centimeters. So that's what you have to do to get to reach the ratio level. When you double or triple or half or cut in a third, that has to make sense, and there has to be a true zero in order for it to reach the ratio level. Okay, so let me go to the next slide here. See if I can copy this so I don't have to redraw it. I'm going to try. Ooh, it worked. Okay, so here's some examples that we can look at and see what they reach. So if we were looking at hair color, does hair color reach the nominal level?
Yes.
Yes. And the answer is yes, because you'll notice here, everything reaches the nominal level. So hair color, zip code, letter grade, ACT score, all of those, everything reaches. Oh, the doorbell's about to ring. My dog's going to freak out. Just a second. Maybe not. Oh, thank you, delivery man, for not ringing my doorbell. Okay, so everything reaches the nominal level. Everything. But does hair color reach the ordinal level? Can you put hair color in order?
No.
No. So hair color cannot be considered ordinal. So it stops at nominal. Remember, it's like climbing up a hill. So you reach the nominal level, but you couldn't get to the ordinal level, so you just stop. You're nominal, but you're not anything else. What about zip code? This one is weird. And I know you could see the answers right here, but zip code is nominal, but it's also not ordinal. Why does zip code not reach the ordinal level? It's a number. You know, couldn't we say 77022 comes before 77023?
Well, isn't it based on geography? So where it would be wouldn't necessarily correspond to the number.
Exactly. Zip codes, for some reason, I don't know why, as a matter of fact, the post office didn't make it a little bit more matching, but zip codes don't seem to fall in any, you know, like if you have a zip code that's a higher number than someone else, it doesn't necessarily mean you live north of them or south of them or east of them or west of them. They're just these kind of random numbers that they threw out. The only thing is that, you know, usually zip codes that are close like this are close together. But other than that, they're just very, you know, very random. And so it doesn't reach the ordinal level because the order doesn't mean anything. So you were exactly right. Like it doesn't really match where you are in the geography of the United States. Does that make sense? Are you guys okay with why that number is not ordinal? Another one that's a number that would only be nominal is a phone number. You know, if you look at somebody's phone number, does that give you any idea of whether they live east or west or north or south, or if they got their number before or after somebody or anything like that? Does the order of phone numbers mean anything? I mean, it may have at one point.
So what would you say about about area codes? I know they're not like really real anymore, but.
Yep. So phone numbers or area codes, which is, you know, pretty related to phone numbers. Those are just nominal because the order of them doesn't really mean anything. Those are a couple of, or, you know, the zip codes, phone numbers, and area codes. Those are all three things that are that rare case of numbers that don't reach the ordinal level, because most numbers reach the ordinal level. They really do. But phone numbers, zip codes, and area codes just really don't. Okay, so now let's look at one that does reach a higher level. What about a letter grade? Is a letter grade nominal?
Yes.
Yes, because everything's nominal, right? Does it reach the ordinal level? Can we order letter grades?
Yes.
Yes. But does it reach the interval level or the ratio level? No, because we talked about that interval, you know, 0 to 59 is an F and 60 to 69. It's not, the intervals are not equal. So we just have to stop at that ordinal level of being able to say A comes before B, comes before C, comes before D, comes before F. ACT scores reach all the way to the interval level. We can name them because you could name everything. Ordinal, because we can order them. We could say somebody that got an ACT score. And ACTs, I think now, they change it all the time. Not all the time, but they've changed it several times. I think they go 0 to 30. Does anybody know? Is it 34 or 36? It's 36 now. It used to be like 32. But 0 to 36. And you could say, obviously, that somebody that got a 20 didn't do as well as somebody who got a 24. You can order them. You can find out what their ACT score was, and you could say this person did better than that person on the ACT. They scored better. Why does it not reach the, so we can order it, there's equal intervals because it goes 19, 20, 21, 22. So we reach the interval level. So we've reached up here. Why does it not reach the ratio level? Does anybody know? I'm talking about ACT scores.
Because how would you measure saying someone's twice as smart as someone if someone got an 18 to a 36?
Right. And so you wouldn't necessarily say someone who got an 18 did half as well as somebody who got a 36. This doesn't mean they got half as many problems right. It's not done like that at all. In fact, when you go from like a 34 to a 35 to a 36, it's very few more questions answered, because what they do is they do a bulk of the questions. A bulk of the questions will be what they consider most people will get, and then they'll have a few that they think a few less people will get, and then they have just a very few questions that they think, you know, those very top people will get. So going from like, again, like a 35 to a 36, or even like a 32 to a 33, you might have only gotten a couple more questions right. It starts to slow down, you know, so like, you know, 18 to 19 might be a difference of 10 questions, 19 to 20 might be 8 questions more, and so on. But again, you couldn't say 18. And even at that, I'm not sure if they would actually give a 0 as an ACT score. I'm not sure it even has a true 0. I think if you take the ACT, then you get a score above 0. I think, you know, if you just put your name on it, let's say, if you just put your name on it and you turned it in, I think they would say it wasn't taken. I don't think they would even score it. If you guessed on all your answers and missed every single one, I think you would still get a score. I don't think you'd get a 0. So I don't think there's a true 0. Okay, height we already talked about. It's one that does reach the ratio level because it's obviously nominal. Everything's nominal. You can order heights. The intervals are equal. You have a true 0 and the ratios. Twice as tall is 20, or 4 feet is half as tall as 8 feet, so on. And same thing with age. And then we talked about temperature does not reach the ratio level. No ratio level for temperature because it doesn't have a true 0, and you can't say twice as hot or half as hot, those kinds of things. So I'm going to leave that at that, and you guys will have some practice on your homework with that. And we'll go from there. Okay, so the next thing that we're going to talk about are data collection and sampling techniques. We already talked about one of these. Do you guys remember, what did I say was the absolute best sampling technique?
Random.
Random. Random sampling is always and forever the best. If you can do it, that's what you want to do. So if you can randomly sample, oh shoot, hold on a second. I had something clicked here and it showed up on the clip. So if you can randomly sample something, that is the absolute best thing to do. What is random sampling? Random sampling is like if you do like there's random number generators on calculators. There's a website called random.org where you can say pick a number between 1 and 100, and it actually uses like the static in space or something like that to pick a number between 1 and 100. Those, you know, random sampling, drawing a name from a hat, rolling a die, things like that, where you assign or pick things based on just something very random. Now, sometimes that's not possible. It's pretty hard to pick. If you were saying the entire population of the United States and you want to randomly pick someone, that's very hard to do. So sometimes you have to resort to some of these other types of sampling. Systematic sampling is when you are looking at something and you pick every kth subject and you're like, what's a kth subject? That means you can put any number in there you want. So you could pick every 10th. So let's say you want to look at the colors of the cars in the parking lot, which is empty right now, right? Because we're all at home. So if you're at the Kingwood campus and you're trying to count look at the colors of the cars, you don't want to necessarily count every car. You don't necessarily want to count just a single row. So you decide, well, I'm going to go in every 10th car, I'm going to write down what color it is. That's systematic sampling because you're looking at every 10th car. But it's not random. Random would be give every car in the parking lot a number, put those numbers in a hat, draw a number out of a hat, go find that car. That's random. This is very systematic. You're going to say, here's the 10th car, here's the 20th car, here's the 30th car. I'm going to write those down. People could be coming into a concert, and you ask every 20th person entering the concert, where did you buy your ticket? Online, at the box office. Almost everybody buys online anymore, but where did you get your ticket, or what city did you come from, or something like that. If you ask every 20th person coming into the concert, then you've done systematic. I'm going to skip stratify because it's harder. I'm going to go to cluster. So cluster is where you use intact groups. So that's where you use, say, an entire class. So if I asked everybody in this class a question, and then I use that to try to make some sort of conjecture about all Lone Star Kingwood students, I used you as a cluster of people. Like you guys are already a group that's together. If you were doing the cars in the parking lot, what would be a cluster of the cars in the parking lot?
All of the red ones?
All the Fords.
Like one row.
All the ones in
There you go.
lot A.
Yep, one row, or just the ones in lot A, or just the ones in this corner. It would be a group that was already clustered together. So when you were saying like Fords or the red ones, those are ones that would share a similar category, like their variable, their data variable was, their data for the variable was the same, but they weren't clustered together. A cluster is something that's already intact before you sample it. So if you looked at it at one row and used that as all those cars in one row as your sample, that would be a cluster sample. Lot A would be a cluster sample. One corner of this parking lot would be a cluster sample. Does that make sense? So it's a group that's already together, clustered together. Okay. If you have questions, go ahead and don't hesitate to ask. But the next thing is convenience samples. Convenience samples are horrible. A convenient sample is where you just, stop somebody. Hey, would you like to take a survey? Hey, would you like to take a survey? Most phone surveys are convenient samples because you have to get the person's approval and so that affects whether or not they're going to answer. You have to, a lot of times, be, in a specific spot, which then means that the people you're sampling have some attributes just from being in that location. It's definitely not random. Does anybody have any questions on random, systematic, cluster, or convenience? Okay.
So
Go ahead.
So like if there was an email sent out, would that be convenient? Like if it's an email survey?
Yes, especially if you only have to answer it if you want to.
So even if it's sent to an intact group, it'd still be considered a convenient sampling technique.
If it's sent to an intact group and everybody answers, that might be considered more cluster.
But if they don't all answer, then it's just convenient.
Yeah, if they send it out to a group and they say, hey, if you want to answer this survey, that would be convenience.
What about like the census when everybody has to answer?
That is, well, they try to make that so it's a population, actually. They try to ask the whole population, but it ends up being a sample. And you're right, it probably ends up being more of a convenient sample than anything because people don't have to answer. They say that you'll get in trouble if you don't answer, but you really don't. And so a lot of people don't answer it. So you're right, it probably is convenience if we had to categorize it.
Is that because like convenience surveys usually have like a response bias? Usually people who are like heavily opinionated, like either good or bad, will be the ones to turn in their survey rather than,
Yes.
like unless they're forced.
Yes, and that's just it. You have when you let somebody decide whether they want to do it, then like you said, if they really believe one way or really believe the other way strongly, they're more likely to give their opinion. You also have, if you think about at the mall, if you stop a mom that's got 4 kids with her, she's going to be less likely to answer. So, well, then you don't have the opinions of moms with 4 kids. But she may not answer just because she's busy. She's in a hurry. An older person might be more likely to answer because they, you know, they have the time and they feel like chatting with someone, or they, you know, that type of thing. So yeah, you're exactly right. You don't get a good sample of the whole population because specific people will answer those surveys over others. Good. Okay, so stratified. This is kind of the most difficult one to explain, but it's actually, unfortunately, used a lot. It's not a really good way of doing things, but it's used a lot. So stratified, remember, think of these words. Random is random. Systematic, you're using a system of every 20th subject or whatever. Cluster is a group. Convenience is, it's convenient but not really good. Stratified, think about what stratified means. We have stratified rocks. That means they have layers, rocks that have layers. If you think of the stratosphere around the Earth, that's the different layers of the atmosphere around the Earth. Okay, so it's these layers. This is why I'm not your art teacher. Okay, so it has these different layers that you have. And so if you're talking about a stratified sample, you might say, I'm going to break everyone up into whether or not they're a freshman or a sophomore. You know, categorized by, you know, how many grades, credit hours they've earned. Are they a freshman or a sophomore? And then within the freshman, I'm going to pick, I'm going to make sure that half of the people that I pick are STEM majors and the other are non-STEM majors. And then out of the sophomores, I'm going to do the same thing. STEM majors, non-STEM majors. And then out of the STEM majors, I'm going to make sure that I get a certain number that are in medical fields and a certain number that are not in medical fields. And the non-STEM, I'm going to pick, you know, whether or not they are, I don't know, English majors or not English majors. And you keep putting these levels on. And so there are these layers of who you're picking. The problem is, when you're said and done, even though you feel like you've done all this fantastic work of getting all these groups represented, does this way that you've sampled that, is that going to represent the population? Does a population of students necessarily equal numbers of freshman STEM medical versus freshman STEM non-medical versus freshman non-STEM English, freshman non-STEM non-English? Are you going to get this balance right? What do you guys think? Would the balance be right compared to the
No.
population? No.
No.
Very unlikely. And what's very frustrating about this, especially for new researchers, people that are just learning the field and such, is you feel like, I've done so much work, this has to be wonderful, because this is a lot of work, you know, to get all these different layers. But just because you did all this work doesn't mean you've represented the population well. So the very best is random sampling. I would say after that, systematic is probably the next best. Cluster and stratified kind of somewhere maybe together. Convenience is horrible. But really all you need to know is that random is the best and the other ones aren't as good. Sampling error, they kind of listed this in this like it was one of these sampling techniques. It's not a sampling technique. It's what happens when the sample doesn't match the population. So when your sample doesn't look like like a small version of your population, that's sampling error. All right, any questions on that? Okay. Again, as you do your homework, I'm sure that, you know, at some point you'll get some wrong, but as you practice, hopefully you'll kind of be able to understand the nuances between the different ones and understand it. That's definitely, sampling technique is definitely something you'll see on the test. If you want to make a little mark of that, there'll definitely be a question on the exam about what type of sampling technique is this. So I'll say some sort of I'll describe some sort of sampling technique, and then it'll say, is this A, random, B, systematic, C, stratified, you know, cluster, or convenient? So that definitely, I can tell you absolutely will be a question on the exam. So I don't try to be tricky about things. I really want you guys to know what's going to be on the exam and understand it. So, all right. lost my slide. Just a second. There we are. Let me put a couple up here just to save our time a little bit. Okay, so let's talk about experimental design next. There's two types of basic experiments, or not experiments, two types of studies. There are observational studies, and that is where the researcher just observes and tries to draw conclusions on the observations. And then there is, I don't like the way they have these sentences set up, so I'm going to circle this. So this whole next paragraph is talking about an experimental study. So there's observational studies and there's experimental studies. Those are the two main types of studies, observational or experimental. In observational studies, the researcher just observes and tries to draw conclusions. In an experiment, they manipulate. Okay. Let me just put that as a general thing. So if you put people into groups, or if you give different groups different medications, or if you give different groups different questions, when you start manipulating anything, that's an experiment. Observational, you just observe. You don't touch or mess with anything. You know, so if you wanted to sit in an area and look at people as they walk by and mark down something about them, say their hair color or something like that, that's an observational study. When you start stopping people and asking them questions, or you start splitting them into groups and having them take different surveys or different medications or different things like that, you're manipulating things, you're experimenting at that point. And within an experimental study, you usually have some sort of explanatory variable and trying to figure out an outcome variable. So let's say you have medication A and medication B, and you're trying to figure out how it affects people's headaches. Your medications would be your explanatory variable. And then your what it does to their headaches would be your outcome variable. So explanatory is what medication you give them, outcome would be headaches. So you're trying to have something that explains an outcome, which medication gives a better result for the headaches. If you want to relate that back to algebra, in algebra, explanatory would be like your X, and the outcome would be like your Y, your input, your output. Your independent and your dependent. These all really mean the same thing. They're just different ways of saying it. This is more of an algebra way. These are more of statistical, independent, dependent, or input, output. Does anybody have any questions on that? Okay. So explanatory and outcome, basically, it means the same thing as X, Y, input, output, independent, dependent. If you get confused, I think most of these input, output, and all of that, people are okay with remembering. But independent and dependent, people get mixed up. So a couple different ways to remember this. Remember, independent is like your input. And another way to think of it is, again, to think of what the words mean. Independent, if you think of an independent person, they're a leader. Ooh, that A looks horrible. They're a leader, whereas a dependent person is a follower. So if you think of X comes first, followed by Y, the input comes first, the independent comes first, followed by the dependent. So this would be, you know, an independent person would be, hey, let's go to the movie tonight. And the dependent person would say, okay. So here the medication says, you know, hey, I'm going to give you medication. And the headache goes, okay, well, I'll react to the medicine. The headache follows the medication. Any questions on any of that? Okay. So the next thing that we're going to talk about in experimental design is different types of mistakes that you can make, basically things that can go wrong. So in experimental design, if you have a sample that is not good, we will call that sometimes a suspect sample. And what we mean by not good is it doesn't represent the population. So if you did a convenience study, that might result in a suspect sample, because we want to know, was the sample large enough? How was it selected? Is it representative of the population? So if you're not sure that the data was collected well, you might have a suspect sample. And when we say suspect, we mean like questionable. Like that's a suspect answer, questionable. Ambiguous averages, if they use in the results of a study, if they use the median or the mode instead of the mean would be like the average where you just add them all up. If they use the median, which is like the middle number, or the mode, which is the one that happens most often, then that's ambiguous averages. Why did you use that instead of the other? The typical way is to give the mean. Why did you use the median or the mode? Are you trying to make things look different? Are you trying to you know, sway the viewer? Or was there actually a reason that you did it? So ambiguous averages, you know, giving the median or the mode without explaining why, because the typical thing would be the mean. A couple other things with experimental designs is when you change the subject, what is that? Okay, when you change the subject, and you guys are still there, right? I don't like that I'm not seeing anybody's faces. You guys are all still there, right? Well, not all, but there's still somebody there, right?
Yes.
Yes,
Yeah.
okay, good.
Yeah.
You guys get quiet and I can't see your faces. I'm like, I'm just talking to myself. All right, so changing the subject and detached statistics and implied connections. Changing the subjects is, it's kind of like the ambiguous averages, but it's where you switch. Like why, like maybe one group you give the mean and the other group you give the median. Like why did you give the mean for one and the median for the other? So when you change the subject throughout the study or between groups, implied connections, we'll talk about detached here in just a second, but implied connections, I love implied connections. This is when they don't really say anything. Studies suggest that some people may understand what this statement means. When you see words like suggest, some, may, those aren't words that you want to see in a research study. You want to say studies support, studies prove, studies, you know, something that's a strong word that actually says something. Suggest doesn't really say much. Some, we don't want some. We want a certain percentage. We want, you know, a certain number. We don't want some. And we don't want maybe. We want do, does, are. We don't want words that are ambiguous like this. So when you see words like suggest, some, may, you know, some dentists may recommend Crest. That doesn't mean that they found anything, you know, that means, I mean, what does some mean?
Like a few.
Yeah, some literally means more than none. So it could be one, some people. That could be one people, one person. It doesn't necessarily mean it's anything more than one. So you'll see things like this a lot in advertising. You don't see it quite as much in, you know, concrete research, but you'll see it in advertising a lot. And another one that you see a lot in advertising is this detached statistics. So they'll say that there's, 1/3 fewer calories. What does that mean? How can you say you have 1/3 fewer calories when you haven't told me what you're comparing it with? 1/3 fewer calories than a different brand? 1/3 fewer calories than you used to have? 1/3 fewer calories than your regular product? What does this mean? If they don't tell you what they're comparing it to, then it's detached. You can't say 1/3 fewer or 30% more or 50% better if you don't say what it's better than or what it's compared. You have to have that comparison basis. And that's called detached statistics. Again, something you see all the time in advertising. They do it all the time. Does anybody have any questions on those? Okay. I wanted to do I'm going to talk about the suspect samples, one other common thing with the suspect samples too. We'll go back to it in just a second, but let's talk about the misleading graphs. Is when you have things on the graph that are not appropriate. I've seen graphs where they make the y-axis go from largest to greatest. Like the bottom of it will be a bigger number than the top number, basically flipping the graph upside down. But it tricks people because they think up is an increase and down. They don't even look at the numbers. Using picture graphs, that's misleading. Not using appropriate scales, or when they don't start at 0. So let's say they start at 100, 150, 200. That's actually misleading because 100 in your brain, you think this bottom should be 0, but it's actually 100. So there's lots of things you can do with misleading graphs. And then faulty survey questions are where you lead people into an answer, usually. So do you feel that statistics teachers should be paid higher salaries? Well, that leads you to say yes. Well, sure, go ahead and pay the statistics teachers more. That'd be wonderful. But this one leads you to say no. Do you favor increasing tuition so that colleges can pay statistics teachers higher? Well, no, because you're increasing tuition. So this question leads you to say yes. This one leads you to say no. So a faulty survey question is when you have a bad question. Now, if you compare that to what we talked to up here, the suspect samples, that's when you have a questionable sample. So people will get those mixed up, the faulty survey question and the suspect samples. The difference is a faulty survey question is a bad question. Suspect samples is a questionable sample. So if I ask people that are coming out of a movie theater, if they, out of a Star Wars movie, let's say, if I ask them if they like science fiction, would that be a faulty survey question? Do you like science fiction? Or would that be a suspect sample? Asking the people that are coming out of the Star Wars movie.
Suspect sample.
Suspect sample, because of course people coming out of a Star Wars movie are probably more likely to like science fiction. So that the sample is bad in that. If I ask random people on the street something like, knowing that Star Wars is one of the top ranked movies ever, do you think science fiction is great? That would be a faulty survey question. You were asking random people. Well, you were stopping people on the street, so that's not necessarily random, but say you could ask random people, but you lead them into the idea that science fiction is wonderful, then you've created a faulty survey question. Okay, so it's not the sample that's bad, it's the question that's bad. So these two get mixed up a lot, and that's the difference. This is a bad sample. This is a bad question. All right, and I think that's it for chapter 1. It is. The last thing, 1.5, just basically says, I'm not even gonna put the slide up. It basically just says, hey, computers and calculators can be used to do a lot of statistical stuff. And it mentions TI 83s and 84s, Microsoft Excel, you can do a lot of statistical stuff. And then there's another one that's used a lot in education called Minitab. We're not gonna use anything like that because, well, we do one time, but we're not in general gonna use most of that because I can't really require you guys to do anything like that, extra money-wise. And so we're going to do most everything just kind of by the most basic methods by hand. All right. Anybody have any questions about chapter 1?
On one of the slides, there was something that said co-founding variable.
Did I
Do we
miss
need to know that?
Did I miss confounding variable? Where was that at? Oh, you're right. Hold on just a second. So a confounding variable, those are actually very interesting. Confounding variables are influences that it influences the dependent variable but cannot be separated from the independent variable. So let's look at, let's say you're trying to do a study on smoking and smoking of mothers during pregnancy and how it affects the birth weight of the babies. Well, you would like to do a study where you can just look at how the smoking affects the birth weight. But that's very difficult to do because there's a lot of things that confound your input variable of smoking. There's been several studies that show that people who smoke are more likely to drink in excess or actually drink at all, but drink in excess especially. So can you pull away that idea of drinking away from the smoking? No, you can't. And so you don't know whether it's the smoking that's affecting the birth weight or the drinking that's affecting the birth weight. Also, it's been shown that people who smoke tend to have a lower level of education. Now, that doesn't mean that everybody that smokes has lower education. I'm just talking in general. It has been shown that there's a correlation between whether people smoke or not and what their education level is. Also, their socioeconomic situation. It has been shown that people who have a lower socioeconomic situation tend to smoke more often. These are facts. These are things that, you know, at least studies have been shown that the socioeconomic may lead to a higher level of smoking. Well, could these things affect the birth weight of the baby? Whether you drink or whether you have a lower education or whether you have a lower socioeconomic situation?
Yeah.
Yes.
Absolutely.
Absolutely. Because we don't know, does the drinking affect the birth weight? Very well does, or very well could. Lower education could mean that you don't have access to as much money. Lower education is lower socioeconomic. You don't have as much resources. You don't have as much knowledge, which means you may not know what's good to do during pregnancy or what's not good. You may not have access to going to the doctor to as good of prenatal care. You may not eat as good or take care of yourself as good, or you may not be able to because you work more. So there's all these things could affect the birth weight, and we can't pull them away from the smoking. So whenever you do a study on how does smoking affect birth weight, all these things confound. These are all confounding variables that affect our output and can't be pulled away from our input. This is actually a very interesting topic that you could probably spend 2 or 3 weeks talking about it alone. But everybody kind of understand that general idea of what a confounding variable is? And what I always like to think of it like a Scooby-Doo thing. Confound you, you kids, you messed up my plan. Okay, so here, the drinking, lower education, lower socioeconomic, lack of health care, all of those things, those all confounded our plan to figure out how smoking affects the birth weight. Anybody have any questions on that? Okay. And there's a few, you know, all of these things, there's a few things in your homework questions that you'll have a chance to practice and all of that. But basically when you're talking about the test, make sure you know what all the basic terminology is out of chapter 1, because that's really all I can do in chapter 1 on the test is ask you like multiple choice, true, false things about the terminology and the setup and things like that. There won't really be any math in chapter 1. Anybody have any questions out of chapter 1 stuff? Okay. So,
yes, I do have a question.
go ahead.
Also, hello, I'm Killian. I don't know if we
Hi.
had introductions
We
at
didn't.
10.
I
Okay.
wish we had. We just are so short on time. But go ahead.
Yeah. Well, I wanted to say sorry. I got here late. Because I kind of signed up for classes at last minute, but because of that, I was wondering if this chapter 1 stuff, like if the slideshow or this lesson has been recorded, and if I could take a look at it at a later date.
Yes.
Yes. Okay.
So the 4 that we're going to do this week and next week, I will. They have been recorded, and I'm going to put them up in YouTube and put a link. So they'll be in the class D2L page. There'll be a link to them. So
Okay.
you can rewatch them, or if you miss them, you can watch them. Yes.
Wonderful.
And there's also notes. Don't forget, if you guys want to print off, let's see if I can get to it, if it's still there. It may have kicked me out because I was gone too long. Nope, here it is still. Okay, so after today, I'll have a link up here that says chapter 1, and there'll be the video that we just did will be here. And if you want to print the notes, they're right here. So if you go to notes and calculator info, the PowerPoint notes for chapter 2 are right here. And what they are is it's the notes that I'm using, and it has some blanks and things so that you can fill them in as we go. So you can do that. And I'm going to try to find my chapter 1 notes and put them in here. Hopefully I have them. With everything being weird, not having access to my office and all of that, I think I have them on my home computer. Well, I have my laptop at home too, so they should be at one of the 2 places. So I will look for that. Anybody else have any questions on anything before we go? Let me try to get back your actual face.
So just, I had a question.
Mm-hmm.
So just confirming that the only 4 live Zoom sessions are the ones that you have on the calendar right now.
Yes.
The
Those.
rest of the class will be recorded.
Yes. So, oh, I just closed that. But anyway, right where I just was, those are going to be, they're already recorded. I already did them before. So, hold on. So they're already there, and I'm not going to hold Zoom classes for them again. But if anybody has questions or anything like that, then I'm happy to, meet with somebody via Zoom or on the phone or send emails or anything. So if any, even though we're not going to have the Zoom classes, see, I've lost everybody. I don't know why nobody's showing up on my screen. That's so strange. But those are already there, and I'm still here to answer questions. I'm not going anywhere after the first 2 weeks. I'm just not going to re-record the sessions. Does anybody have any questions on that? Okay. And if we need to do...
Will you have like, I guess like if we have questions, like office hours or anything through Zoom or something?
Yeah, that's what I mean. Like, I'm not going to do anything at a specific time, but if anybody wants to talk to me, we can set up a Zoom and chat, or we can talk on the phone, or we can talk back and forth via email. So that's what I mean. Like, I'm not going to set up a specific time because everybody's time is different. So if somebody needs to talk to me, send me an email and we'll set up a Zoom and we'll talk. But I'm only going to do the 4 actual live sessions. So we're going to do chapter 2 on Thursday. And chapter 2 is mostly on graphing, tables and graphing.
And just to confirm, you did say later on that there would be like review sessions or?
Again, I'm probably not going to hold live review sessions,
Okay.
but there's ones already there. Oh, I shut it down so I can't show you. But in the videos, there's live review sessions that I've done in the past with classes.
Okay.
And then there's also, if you look in the review module, there's Kahoots that I've set up that you could like go through yourself. And then there's printed ones. There's all kinds of things in the reviews.
Awesome. Thank you.
I had a question in terms of like calculators and stuff like that. Are we allowed to use I don't know if you know the program R? It's like a online sort of calculator thing. Are we allowed to use those or?
Like during the test?
Yeah.
During the test, the only calculator that you'll have access to on the computer is the one through Respondus, but
Okay.
it's there. There's a scientific calculator. I would probably recommend, if you can, to get a scientific calculator, a graphing calculator that you can use separate from that.
Okay.
Just because, I mean, and you're welcome to use that other one when you're doing your homework.
Okay.
And just Respondus probably won't let you pull it up.
Mm-hmm. All right. Thank you.
Mm-hmm. And on that note, so you can use a calculator during your tests, and you can also use, there's a, if you look in Connect Math or you look in D2L, it's both places. There's important formulas and tables, and you can use that on all the tests.
Okay,
so you don't
great.
really have to memorize you don't have to memorize formulas. You have to kind of memorize procedures, ideas, concepts, but you don't have to memorize the formulas.
Okay, great.
And we can kind of talk about that as we get into some formulas and such, which will be like, we don't really do that till chapter 3, I think it is when we start kind of getting into our first formulas.
Okay.
Anybody else have anything?
What are some, I guess, study tips you suggest?
Do your homework. That's my biggest study tip. Do your homework, do your homework, do your homework. And watch the videos. I would say the videos that are in Connect Math are good, but since I'm the one that wrote the test and all of that, I'm the one that decides what I think is important to put on the test. Probably watching my videos is better, and I'm not trying to be like, I'm the best teacher ever. I just, since I'm organizing the class and writing the tests and all that, I think that, and I don't have to be, one of the problems with publisher videos is they have to be careful about being very mathematically correct in all of those things. I don't have to worry about that. I can explain things, in a goofy way or a weird way, and just however I think will help you guys understand it, where when you're doing publishers videos that are being, put out there for everybody to see as these professional level videos and all that, then they feel compelled sometimes to be very rigid, if that makes any sense. So I would watch the videos in D2L over the videos in Connect Math, or watch both. Does anybody else have any questions? Concerns? Anything? And yes, I'm sorry I didn't have everybody introduce themselves. I'm glad people were able to make it today. Again, if there's a time you can't make it, you can, it's not obligatory, and you can watch it, the recording of it. Like for right now, I have it looks like 1, 2, 3, 6, 7, 8, 9, like 12 people here. There's like 60 people enrolled in the class. So those other people are not going to have any kind of anything negative happen because they weren't here. And hopefully they'll watch the recording. Anybody have any other questions? All right. If you don't think of it now, but you think of it as soon as we, get away from the meeting, feel free to email me. And otherwise, I will see people on Thursday. So everybody take care, and we'll see you on Thursday.
Thank you.
Thank you.